frequency response. So the components. So the aim of our experiment today is to construct a first order active band reject filter using T network. So in this T network we are using a resistors and a capacitors, and for the amplifier we use an IC voltage follower circuit IC 741. So the experiment is to construct it and to study its frequency response. So this circuit, what we are showing is the circuit which consists of a T network of two resistors R and two capacitor, and the R by 2 I2C which are in parallel network. So this resistors which are in T is working for our band elimination filter. So now in a band elimination filter or band stop, or we call it as a band reject filter, which is a predetermined of frequency are attenuated in a stop band region while they are passed out in the band pass. So this passive filter section consists of 2T network, that is the reject frequency at which we have the frequency R is equal to 1 by 2 pi R into C. As a passive T section has a relative low figure of merit Q and a voltage follower using our IC 741 significantly increases the Q point. The most common use of the active narrow filter is eliminating filter is to remove the undesired frequency like 50 Hz humming in the biomedical instruments and other circuits. So to study this part or to construct this part, so we construct this circuit by having our two resistors. This is a T-shaped network, two resistors which we are going to have. The resistors of the value which we are taking is the resistors 3.9K. So two resistors which are in 3.9 and 1.92 resistors of 1K which are taken in series. And we have a two capacitors of 0.01 of two capacitors and 0.02, that is the value of 2C, and the output of this is connected to the pin number 3 and the pin number 2 is ground to pin ground point. So the output of this point at this is given to the output where we will be measuring the connecting to the CRO. As we see here, the pin number 7 is connected to the plus VCC of 12 volts and pin number 4 is connected to the minus 12 volts, and it is a ground point, virtual ground. So as you see our connections, all these are connected and we have to study the frequency response. So when you look to the frequency response, as we go on increasing the frequency, the output gain of this band elimination should go on decreases. As by seeing our designing frequencies, which we know that calculation 1 by 2 pi R into C. So we have designed in such a way that designing is for 4K. So for 4K we should have got theoretically the minimum output voltage. So by constructing this, R by 2 value is 1.99 and we are taking into our circuit 2K. Instead of getting the 1.9, we are putting into two series resistors of 1K and 1K. It is approximately equal to 2 kilohertz. And this is the expected waveform what we are expecting from the graphs of the reading tabulation. So now you can observe our tabular column by adjusting the frequency from 100 to 20. Now we start taking the readings from 1K, 2K, 3K and 4 on, correspondingly noting down the output voltage and output gain. So when we see this, our signal generator, when we see that this signal generator frequency which we have adjusted it for 1K, you can observe this is the input voltage, the upper one is the input voltage and the lower one which we are seeing is the output voltage. As you go on varying the frequencies, so according to our concept, if I increase the frequency, that is for 2 kilohertz, so for this 2 kilohertz, what will happen to our output? When we can see exactly what is the output. So the output voltage is decreasing. Further, if I increase it for 3 kilohertz, so for 3 kilohertz, if I am going on increasing the frequency, Continuously you can keep observing the output voltage. Again the output voltage is decreasing. Further our designing is for 4 kilohertz. So if I see that 4 kilohertz frequency, if I set it, for the 4 kilohertz designed frequency, we are supposed to get the minimum output voltage. Yes, for this minimum we are going to get, that is the minimum output voltage, which is for our designing frequency. Further if I increase, yes, further if I increase for 5K, the output increases. So 6, 7, 8, so continuously the frequency goes on. Means it shows that for the design frequency of 4, we are going to get a minimum output, that is a band elimination. So this band elimination at 4 kilohertz what we have designed is being seen here. 4 kilohertz is the design frequency FR, which is the minimum. For the designing frequency of 4K, the output which we have got from our reading of the observation of the tabular column, which is at a minimum. From this graph we can say that this is the design frequency FR. This FR and this theoretical and practical should be coincidence, nearly approximately. There is a small variation because of taking 1.9. We have taken a 2 kilohertz or 2K registers. So there is a slight things variations if it has gone into wrong. And as you go, so as my frequency increases, that is from 1K which we have seen, it is going to remain constant, decrease 1K, 2K decreases, 3K, 4K. Exactly at 4K it is a minimum, and further if I increase the frequency 5K, 6K, and it is increasing. So this is the nature of the waveform what we are observed from the readings which we have plotted from our tabular column. So to taking into consideration, to have a maximum, the value is 1 is again the maximum, and at 0.0707 we cut off the frequency this. So at this point we drop to frequency towards our x-axis where we have the frequency. So this is called as the H higher frequency, and this is a FL lower cutoff frequency. And middle of these two, whatever we get at center point where we have a middle, this minimum point we call FR. This is the expected FR, which we call it is a band elimination point, in which we have this point at which it cuts FR must be equal to the designed frequency of the FR. So these 2 points at which we calculate, this is called as the bandwidth of the things. So this bandwidth is used in order to calculate the Q factor of us. So the quality factor which we are going to say, as in our theory we said that the lower the figure of merit, Q factor. So here Q should be less because it is a narrow band pass filter and a band reject also we call, and some says it is a stop band frequency. At this the frequency is very minimum. So we can observe the things as we see the gain also respectively decreases and increases. So this circuit which we are doing it for these used usually in the medical fields where we have to reject the applications of this, what we are going to see is for the medical application, especially for particular frequency where we do want to have the minimum output, and further if you see it can be increased according. So this is an experiment where we can conclude that from the graph we say that for the design frequency the output is a minimum, and for other frequency as the frequency increases it decreases, further above the cutoff frequency still again the output goes on increasing. So this is what we have done, determining and studying of the bandwidth of the frequencies of the band elimination filter circuit.